Okay, in this problem we're asked to find the simplest form of each fraction. So in this first problem here we've got a squared minus b squared divided by 3a minus 3b. So the way we're going to go about this is we're going to factor. And you may recognize this a squared minus b squared is a difference of squares formula. And the difference of squares formula is basically this. If you have a plus b times a minus b, it's equal to a squared minus b squared. Now you can prove that by distributing here. So a times a is a squared. A times negative b is negative ab. B times a is positive ab. And then b times negative b is negative b squared. And you'll notice that the two middle terms cancel to give you a squared minus b squared. And thus you have a difference of squares formula. So we're going to use that to write the numerator as a plus b and a minus b. It factors it. Okay, and now let's look at the numerator. And we can't use the difference of squares formula here because nothing's being squared, but we can factor out a common term. And you'll notice both of them have a 3 in front of them. So we can pull out a 3, factor it out. So if we factor out a 3 out of this, basically divide it out, 3a divided by 3 would just leave the a. Likewise with the negative 3b, if we take out the 3, we just leave the negative b. Okay, so given that, we can reduce the a minus b that's in the numerator and the denominator, and we get a plus b over 3. And that's reduced. Okay, let's take a look at the next problem. We have 14x squared times y divided by 63x y squared. Okay, so we're going to factor again, kind of like we did up here when we factored out the 3. What was left, we're going to do the same thing here. We're going to try to see what is the biggest thing that we could factor out of both the numerator and the denominator, and we're going to do that. Okay, so let's start with a number. 14 and 63. Do those have any common factors? Well, 7 goes into 14 twice, and 7 goes into 63 9 times. So 7 is a common factor. So I will factor a 7 out, okay, for the number. Now let's look at the x squared and the x. The smallest power of x is the one that we're going to factor out. We can't factor out more than the denominator has here, so we can only factor out an x. Okay, so we'll factor out an x on top and bottom. Okay, so far we're factoring out a 7x. And then we'll look at the y. Again, we have to look at the smallest power. This is y to the 1, this is y to the 2, so we can factor out a y to the 1, or just y, out of the numerator and the denominator. Okay, so what does that leave? Let's look at the numerator. So we have 14, we factored out a 7, that leaves a 2. We have x squared, we factored out an x, that leaves still an x. And then we have a y, we factored out a y, then it's gone. So the top, after we factor out a 7xy, gives us 2x. Now, in the denominator, 63, if we factor out a 7, divide, gives us a 9. Okay, and then we've got x and x, so they're gone, they're both gone. So we don't have to write an x inside here. And then we've got the y that comes out of here. We've got y squared, but we're only taking away a y, so that'll leave a y left. Now the reason we did this is because now that we have a 7xy times 2x and a 7xy times 9y, we can do this. We can reduce those factors. And that will leave us 2x over 9y. And that is reduced as it can be. Okay, let's take a look at another problem. So for this one it says, determine if the following pairs are equal. Okay, so how are we going to go about finding if these things are equal? Well, we take a look at the 3/8, and that's as reduced as it can possibly be. All right, there's nothing that divides into 3 that will also divide into 8, except for 1, but 1 won't help us at all. So this is as reduced as it can be. So let's try reducing this fraction here. So we take the 375, and we start dividing it by common factors in the numerator and the denominator, just like we did earlier. Okay, so common factors. Since it ends in a 0 and it ends in a 5, we can say, okay, well, they're both divisible by 5. So we could say, okay, we take a 5 out, and then we take a 5 out. Okay, so if you divide 375 And you could use a calculator for this, or you could do some quick math on the side if you want. I'll just go with the calculator. 375 divided by 5 gives us 75. And then 1,000 divided by 5, which you might be able to do this in your head, is 200. Okay, now let's divide by 5 again, because it also ends in a 5 and 0. Okay, so we divide by 5 again, so that means now we have two 5s out in front of both the top and bottom. Okay, so if we divide 75 by 5, we get 15. And if we divide 200 by 5, 40. Okay, and at this point, you should be able to start doing this in your head without a calculator. Maybe you were able to before with a little bit of work. But at this point, we can see, okay, well, it still ends in a 5 and a 0, so we can take out another 5. And 15 divided by 5 we know is 3. So that completes the top, because these are all prime numbers. Okay, you can't reduce that anymore or factor it anymore. Now we divide the 40 by 5, and that's an 8. So we get 5, 5, 5 out front, and then we get an 8. Now, just like last time, since we've got this completely factored, we can say, let's reduce all those terms, and what do we get? We get a 3/8. So determine if the following pairs are equal. Is 3/8 the same as 375 over 1,000? Well, yes it is. Okay, let's take a look at 18 over 54 and 23 over 69. Okay, so the 18 over 54 and the 23 over 69, we need to try to reduce both of these this time, because it looks like both of them can be reduced. So let's start with the 18 over 54, and let's just reduce that thing as much as we possibly can. Okay, so it looks like you may see that an 18 goes into the top and bottom, but let's start a little smaller. Let's say we divide it by 3. Okay, so that'll give us 6, and then you divide that by 3, you get 18. Okay, and then we divide another 3, so 3 times 3 times 2, that means the numerator's done. And then 3 times 3 times, if we divide that by 3, we get a 6. Okay, we could take it one more step if you wanted. 3 times 3 times 2, and then 3 times 3 times 2 times 3. Okay, that's the 6. I should have changed those over, but it helps me do this. Reduce, reduce, reduce. Now, if you reduce everything on top, don't just write down, oh, my answer's 3. No, your answer's not 3, because remember, this was 18 over 54. Okay, the numerator is smaller than the denominator. It can't be a whole number. So put a 1 on top. If everything reduces, put a 1 on top. So we get 1/3. So 18 over 54 is equal to 1/3. Okay, let's try the 23 over, not 29, 23 over 69. Excuse me. Okay, 23 is prime. 23 is prime. So we can't reduce that at all. Let's look at the 69. 69 is divisible by 3, because 3 goes into 6 and 9. Okay, so if we divide it by 3, what do we get? Well, we get 23. Well, that's convenient, so we can do this. But again, remember, your answer is not 3, it's 1 over 3. Since everything reduced on the top, you have to put the 1, so 1 over 3. So are these two fractions equal? Well, yes. As a matter of fact, they are. Okay, let's try this one. If a fraction equals 3/4 and the sum of the numerator and denominator is 84, what is the fraction? Okay, so we've got 3/4, and we want to be able to add these two numbers up and get 84. Well, if we add these two numbers up right now, what do we get? 3 plus 4 is 7. Okay, so 3 plus 4 equals 7. But we don't want 3 plus 4 to equal 7. We want a number plus a number to equal 84. So how do we make this 7 turn into an 84? What do we multiply it by? Well, how many times does 7 go into 84? Use your calculator if you need to. It goes in there 12 times. So if I multiply this side by 12, what do I have to do to the other side of the equation? Yeah, I have to multiply it by 12. Okay, so I get 12 times 3 and 12 times 4 when I distribute this. So 12 times 3 plus 12 times 4 equals 84. Let's make sure that this is actually a true statement. So you get 36 plus 48 equals 84, and you can add that up quickly and see that that is true. Okay, so how did that help me solve the problem? Well, what I did here was I multiplied the numerator and the denominator by the same number. Is that something I can do and get the same fraction? If I multiply both the top and the bottom by 12, is that okay? Well, yeah, it is okay. It's not going to be reduced, but it will be a proper fraction. So 36 over 48, we know if we divide both of these by 12, it'll reduce back into 3 over 4. So it equals 3 over 4. These 3 over 4 is equal to 36 over 48. And we also know that if we add these two up, we get 84. Okay, so our answer is 36 over 48. All right, one more problem. Find two rational numbers between the given fractions. Okay, rational numbers means that you can't just type 3 over 7 into the calculator and then 4 over 7 into the calculator and then try to change that decimal by 1. Okay, that wouldn't work. Okay, that's not what they want you to do. What they want you to do is keep this in fractional form. So what we're going to do is try to change the denominator. Now remember, we're trying to find two numbers. Okay, two rational numbers, not just one number in between 3 over 4 and 4 over 7, or 3 over 7 and 4 over 7. We're trying to find two. Okay, so let's first try just multiplying the top and bottom of both of these by 2. So if I multiply by 2, 3 over 7 times 2 on top and bottom, and 4 over 7 times 2 on top and bottom, that would give me 6 over 14 and 8 over 14. Okay, is there a number between 6 over 14 and 8 over 14? Well, yeah, it's 7 over 14, right? So 7 over 14 would work, and 7 over 14 happens to reduce to what? 1/2. Okay, because 7's half of 14. Okay, so one of the numbers we could use could be 1/2. Okay, but since we're looking for 2, we could do this a different way and not have to do it twice. We could just multiply this by 3 instead of by 2, and we should open up more numbers that are between these two numbers. So let's multiply by 3. So 3 over 7 times 3 on top and bottom, and 4 over 7 times 3 on top and bottom. Okay, that will give us 9 over 21 and 12 over 21. Okay, now can we find two numbers that are between these two? Well, sure, 10 and 11, right? 10 over 21 and 11 over 21. So we actually ended up finding 3 rational numbers between. And how many could we have found? How many rational numbers do you think there are between 3 over 7 and 4 over 7? Well, if I multiplied it by 4 instead of 3 on top and bottom, I would open up even more possibilities. And if I multiplied by 5 on top and bottom on both of these, I would open up even more possibilities. And I could do that and keep doing that and keep doing that forever, because there are infinitely many numbers between 3 over 7 and 4 over 7. There are infinitely many numbers between any two numbers that you choose. Let's move on to B. -7 over 9 and -8 over 9. Okay, we need two numbers, so let's just go ahead and multiply it by something like 3 or 4 even. I'll start with 3. So -7 over 9 times 3 on top and bottom, and -8 over 9 times 3 on top and bottom. And you may be wondering, what's this negative sign going to do? What is it gonna change things? Well, no, it's not going to change things at all. Okay, we're still going to go through the exact same process. So this becomes -21 over 27 and -24 over 27. Okay, so what are the numbers? What are the two numbers that we can find between those two numbers? Well, we have -22 over 27 and we have -23 over 27. Those are two numbers that are between -7 over 9 and -8 over 9. Now keep in mind that we could find infinitely many numbers if we wanted to. If I wanted to multiply this by 4 on top and bottom, I could get even more choices. Okay? All right, last one. So we've got 7 over 8 and 5 over 6. Okay? So let's do the same strategy that we've been using. Let's multiply by 3. Well, you know what? Let's change it up. Let's multiply it by 4, because we can do that. So 7 times 4 over 8 times 4, and 5 times 4 over 6 times 4. Okay, so that would give me what? 28 over 32 and 20 over 24. Okay, so does this strategy work this time? Okay, what's different about this problem than we've been looking at? Okay, well, when we multiplied by the same number on top and bottom, we've got different denominators here. So what happened? What went differently? Well, it's because we started with different denominators. Okay, so since we started with different denominators, the first thing that you probably want to do is try to get those denominators to be the same. Okay, so we're gonna tackle this in a slightly different way. Let's start again with the 7/8 and the 5 over 6. Okay, so the first thing we want to do on this is find a common denominator. Okay, so to find a common denominator, we could just say, well, 6 and 8 both go into what? 6 times 8 is 48. That would work. Or we could say, okay, well, what's the smallest common denominator that I could have? Okay, well, if you factor out a 2 here, you get 7 over 2 times 4. And if you factor out a 2 here, you get 5 over 2 times 3. Okay, so in order to find the least common denominator out of these two, you multiplied the common 2 and then the uncommon things, which is 3 and 4. 2 times 3 times 4 equals 24. So that's your least common denominator that you could find if you're looking for that. Okay, so we're going to try to turn these two into both having a 24 denominator. That means this needs to be multiplied by 3, because 8 times 3 is 24. And this needs to be multiplied by 4, because 6 times 4 is 24. Okay, so that gives us 21 over 24 and 20 over 24. Okay, now, did that give us two numbers in between those two that we can use? Well, it did not. It did not give us two numbers that we could use. We can't use 20.5 over 24. So let's try tripling this like we did the other problems. Let's try multiplying the top and bottom by 3, and then we can get numbers that fall between. Okay, so 21 times 3 is 63. 24 times 3 is 72. Okay, and then 20 times 3 is 60. And then over 72. Okay, did that give us two numbers that fall between 7 over 8 and 5 over 6? Well, yes, it did. We've got 61 over 72. And we've got 62 over 72. Now, this one could be reduced. If they're asking you to reduce something, well, go ahead and reduce it. So you could say 61 over 72. I do not believe that one can be reduced. Then you've got 62 over 72, which divided by 2 equals 31 over 36. Okay, so there's two numbers that are reduced and in between 7 over 8 and 5 over 6.